Explain how a pattern of neural inputs generates a unique pattern of neural output. So this question is an extension of the previous question and is the really key to understand how synapses represent memories, or the strength of synapses more correctly. All right, there's a lot going on here, and let me walk you through it. In the top left, you see those presynaptic inputs that we mentioned in the previous video. And those inputs are connected to a bunch of postsynaptic output neurons. Now, the key here, like I said in the previous video, are the purple dots. Those represent connections that are strong. And remember that without a strong connection, neuron A firing might not trigger the firing of another neuron. Now, in this case, neuron A firing would trigger neuron 1 firing, and neuron A firing would trigger neuron 2 firing because there's stronger connections as evidenced by the purple dots. However, neuron A firing won't trigger neuron 3. The only neurons that trigger neuron 3 are B, C, and D. So if B, C, and D are activated, then neuron 3 will fire. And if an A and E happen to be activated, it doesn't influence neuron 3. Now, on the right-hand side, there's a bit of math. Now, I'm going to walk you through this and see what happens. So the X1, X2, and X3 are different patterns of neural input. A 1 just signifies that the neuron is activated and firing. So for X1, neurons A, B are firing, C is not, D is, and E isn't. Now, how do you know what actually happens? Well, basically, what happens in this case is there's multiplication. The strength of the synapse is assumed to be a 1. If it's strong, a 0 if not. So when neuron A is activated, there's a 1 in position X1, you would multiply that by the 1 and see the memory recall that is happening. And this is repeated throughout the matrix. So the key to understanding this problem is to work through how this matrix represents the information. Now, what's really cool here is a unique input gives you a specific unique output. And that's the trick to understanding this problem. If you can realize that those unique outputs are your memories, it's a pattern of neural activity, which might be your memory of what a neuron is. It's a pattern of neural activity, which could be your memory of last night. And the key is in the math. The inputs multiplied by the synaptic weights give you the outputs. And that's the most important thing you could do right now, is work through that bit of math and see how it works. We'll talk about that a bit more in the next video. I'm just introducing the concept here. But again, the key idea is that the reason you can say that synapses and layers of synapses are memories is that a unique pattern of input gives you a unique output. These are your memories.